How about 8, 9 questions there? I don't remember which numbers you had. I don't remember which one. We only had a couple, but I don't remember which one. Okay, so 2, you want me to do 2? No? 5? Give me 1. 9?
No, not 10.
9? With the trig function? All right, y equals the square root of sine x. Y equals 0. X equals 0. Abby, I apologize. I cannot find my football that I used to show them. Yes, I've had it for years. Oh, how did you remember that? Holy cow. Okay, so here's what we're doing. This is the x-axis, right? And this is a curve. We'll say this is like a circle, equation of a circle, right? We take this solid that forms by rotating the area here in between the x-axis and the shape. Watch, here's where the math happens. And it makes a three-dimensional shape. And so that's what we're finding the volume of. And so what happens is, if we cut slices out of this each time, you know how we were doing the shapes on top, but it was the cross sections? This time it's always going to be a circle, right? Because no matter where I cut, since I'm revolving all the way around 360 degrees, it's going to be a circle. So the distance then from the curve down to the x-axis is the radius of that circle instead of the diameter. And so the area is still the integral. It would be the integral from, I'm so nervous they're going to come on. Okay, so it's going to be the integral from here to here. And then we'll do the area of the circle formula, right? Just like we were doing the cross section. So it's really not that bad. Okay, remind me where I put it. All right, so what we're going to do first is graph y equals sine x. What does that look like when you graph it? Square root of little semicircles in random places. Okay, so the first thing I notice is that I'm going from x equals 0 to x equals pi, right? So I'm just going to make this pi. And when I graph it on the calculator, I do see it going, this is half pi. It looks like it goes up to 1. It does something like this. In this interval anyway. Are we all okay there? And this is y equals square root of sine x. Yes, she needs us this block. All right. So let's find the area. Remember, I'm looking for the area of just one circle because then I'm going to integrate that from 0 to pi, and that's going to give me the volume that's rotated around. So this distance is what? Well, right there, but what about right here? Square root of sine x. And that is what on my circle? The radius of the circle. All right, so remember area of a circle is pi r squared, so I'm going to do pi times, what did we say the radius was? Square root of sine pi r squared. Are we okay with that? Everybody good? All right, so now to find the volume, I'm going to go from 0 to pi. Yeah, it will. And what I'm going to do, I'm going to pull this pi out here. Because really it's just a constant, right? And inside I have sine x. I have the solutions posted now. I did not before. I'm sorry. So now what's the antiderivative of sine x? You don't have to solve it? Oh, boo, hiss. This is an easy one to solve. Okay. Let's solve it together anyway, just because we can. What's the antiderivative of sine x? Negative cosine x. So I'm going to do pi times negative cosine x evaluated from 0 to pi. What's the cosine of pi? And there's a negative in front, so this is actually going to be, it's going to be positive 1, right? And then the cosine of 0, 1. So I end up with 2 pi as the volume. Not too terrible, right? What else? Same 8-9 or 8-10? 8-10? 4. Let's see. We got y equals x cubed. We got x equals 0. We got y. I always have to draw a picture to be able to see it. And we're revolving around the line y equals 8. All right, so let me just put everything on my graph here. Here's x cubed. X equals 0. Y equals 8. Not a color. Can you see the shape already?
Oh, I didn't.
But I'm not revolving around the x-axis. I'm revolving around this line, right? So I have to take that into account. So remember, I still need my area of my circle. And again, I'm going to need this point because that's how I know I'm going from 0. But then what am I going to? What's that x value? Well, I got to figure it out, right? So at this point, y is 8. So where, if y is 8, x would be 2 there, right? So I'm going to go from 0 to 2. This point would be 8, 2. So now the area of the circle. So to find the area of the circle, of course I need the radius. The radius is the hard part here because the radius is stretching a little bit easier because it's not diameter, right? I don't have to take half of it at least. It's not a cross section, but I've got all this space here that I do have to account for. So I know that this is from here to here, that distance, x cubed, right? Exactly. So, and the whole thing is 8 because I go up to y equals 8. So to find the little green area that's left, which is the radius of my circle, I need to do 8 minus that whole x cubed. Does that make sense? So the area of my circle is going to be pi, and then I got 8 minus x cubed squared. Again, this is a setup, but do not evaluate. So I'm going to do pi times 8 minus x cubed squared dx. It's assumed at this point you could evaluate, right? Especially a polynomial like that. I'd need to FOIL that out. No, it would not. That's fine. What else? You want me to evaluate it? So I would need to do this. 64 minus 8x cubed minus 8x cubed plus x to the what? 6, not 9. I add because I'm multiplying, right? All right, so I get pi times the integral from 0 to 2 of x to the 6th minus 16x squared plus 64 dx. Antiderivative of x cubed, 1 over 7 x to the 7th minus 16 thirds x cubed plus 64x, all evaluated from 0 to 2. Oh, it should be cubed here. That's right. So this is going to be 4, which means this is 4, which means this is 4. Thank you, Drew. Look at you. That makes life a lot easier. Pi times 1 over 7, 2 to the 7th minus 4, 2 to the 4th plus 64, 2. And I don't even need that 0 because everything's got an x on it. It's just going to be 0, right? 2, 4, 8, 16, 32, 64, 128. 2, 4, 8, 16. 16 times 4, 64. 128. That's what I was looking though. One, it goes in one time, it'll leave you 558. 7 doesn't go into 58, so no. This would be plus 64. Whatever that comes out to be.
Oh.
128 over 7 plus 64. I can't do 64 times 7 in my head. That it's Monday. Plus 64. 576 pi. Yeah. Yeah, you didn't have to. Just that's okay because you need to know how to evaluate an integral. Where's my missing? What else? What you think? Y'all seem to be better with this than the other stuff. It's surprising because this is usually the hardest. Ready to put a hole in that? Here we go. I feel like we should do something celebratory or something. It's the very last lesson of calculus, you know. Yeah, this is it.
I can get a save video for 5 minutes.
Yeah.
I did that last year for history. I was like, I'll just bring 2 minutes. I don't have to.
You must go to Chick-fil-A a lot.
Not really. I just never use my points.
Yeah.
Because I'm gonna
They expire on you if you don't use them though. Yeah, it takes a long time.
I mean, 9,000.
I want you to look at this one and try to rotate it and tell me what you think the problem is. So graph it and look at it and see what happens. It's the same question. It's the same thing. Rotate it about the x-axis and find the volume. I should do it in a different color. What am I rotating about? Do you see that funny little shape that I'm rotating? It's going to leave space. That's exactly right. Can you visualize that shape that's occurring as it rotates around? It's hard to see them. It really is. But it's hollow inside and it's kind of coming out, bowing out like a trumpet on the end, right? Do you understand what I'm saying? As it rotates around, but the solid as it comes around has a hole, but it's all meeting down at the end. Okay, hold on. Look at this one. Or this looks exactly like the one we're doing. Oh, it is. Look, it's the same one. There we go. See how it's rotating around this way? It's creating this open part in the center. Like a funnel inside with this three, yeah. The green line would be the radius of the solid, so this part would be where it's open, all of this, yeah. Yeah. That makes sense? Do you see what we're doing? So, now the question is, how do I find that volume? Because volume is still the same thing. It's the integrated area, right? So I need to know the area of the circle that's happening. But what I have to do, because we all see this big fat hole that's here, right? I call this, no, y'all know I'm quirky. I literally call this the hole. They call this a washer because think about a washer, it's got a hole in the middle, right? So I think about this as two separate circles, and that's just the way that I do this. And I say that from here down, this is the radius, because I'm still talking in terms of circles. I'm going to say, oh my gosh, radicus. Radius of the hole with a W. So the whole thing's radius down to where it's rotating around. That would be that distance. Do you agree? Can you see that? And then I say that this from here to here would be the radius of the hole. Does that make sense? So when we integrate what we can do from whatever to whatever, we do the area of the hole minus the area of the hole. Does that make sense? Nope, Hold on a second, y'all. Hold on just a second, because I'm going to make sure. All right, so setting up here. What is the area of the whole? Square. Okay, so I got, remember it's pi r squared, right? So it's pi, what's the radius? Square root of x squared. Right? Which is just pi x. What's the area of the whole? Like h whole. So pi times x squared squared, pi r squared, right? So I get pi x to the 4th. Now if I want the volume of this as it rotates around, what am I going to do? How do I know my bounds? You see where they equal, where they intersect. Where does the square root of x equal x squared? What is this point? We know this is 0, 0. So I know I'm going from 0. Think about this in terms of should be what? 1, right? 1, 1, right? So I go from 0 to 1. Does that make sense? And I'm going over x, so I'm going to use the x value. All right, so now I'm going to do volume equals. And this is where you can still pull the pi out and leave it off of each one because you're doing both of them. But you got to make sure you get the right one first, okay? So the whole thing, which is pi x, right? Minus the whole, the h whole, pi x to the 4th. I could have written it this way also because they are both multiplied. I could kind of factor that pi out. And it just makes my integral a little bit easier. Now if I evaluate this, I get pi times, what's the antiderivative of x? And the antiderivative of x to the 4th, evaluated from 0 to 1. A half minus a fifth would be 3/10. Is that right? There's your whole. What do y'all think? It's not bad? This was kind of an easy one. Well, you're finding the area of, you're taking the whole out. You see what I'm saying? You're finding the area of the whole thing, and then you're subtracting out the area of the whole that's in the middle. That's the. I'm sorry. This is the volume of the solid. This is the volume of the solid that we were looking for. This is the end of the problem. This is the volume of the solid rotated about the x-axis. It gets harder as we rotate around different axes or start shifting, and you have to really visualize that hole, that H hole.